it's me again. This is part 4 of question 3. Where did the instructions come from? There we go. Replication, how DNA is copied. 1. This part of the ENZYME machine splits the DNA into 2 separate strands. 2. This part of the machine takes in a single strand of DNA and uses it as a template to create a double strand. 3. Ring-shaped sliding clamp that guides and stabilizes the ENZYME machine. 2 complete DNA strands are formed. A book with no author. Despite advances in mineralization, no man-made information storage device can approach such a capacity. Yet the compact disc offers an apt comparison. Consider this: a compact disc may impress us with its symmetrical shape, its gleaming surfaces, its efficient design. We see clear evidence that intelligent people made it. But what if it is embedded with information, not random gibberish, but coherent, detailed instructions for building, maintaining, and repairing complex machinery? That information does not perceptibly change the weight or the size of the disk. Yet it is the most important feature of that disk. Would not those written instructions convince you that there must be some intelligent mind at work here? Does not writing require a wider? It is not far-fetched to compare DNA to a compact disc or to a book. In fact, one book about the GENOME notes, the idea of the GENOME as a book is not, strictly speaking, even a metaphor. It is literally true. A book is a piece of digital information. So is a GENOME. The author adds, the GENOME is a very clever book because in the right conditions it can both photocopy itself and read itself. That brings up another important aspect of DNA. If DNA were the size of a railroad track, the ENZYME machine would be moving at the rate of over 50 miles per hour. Machines in motion. As you stand there in the quiet, you find yourself wondering if the nucleus of a cell is really as still as a museum. Then you notice another display. Above a glass case containing a length of martyr DNA is a sign that reads, push button for demonstration. You push the button and a narrator explains. DNA has at least 2 very important jobs. The first is called replication. DNA has to be copied so that every new cell will have a complete copy of the same genetic information. Please watch this simulation. Through a door at one end of the display comes a complex-looking machine. It is actually a cluster of robots closely linked together. The machine goes to the DNA, attaches itself, and begins to move along the DNA as a train might follow a track. It moves a little too fast for you to see exactly what it is doing, but you can easily see that behind it there are now two complete DNA ropes instead of one. at once. The narrator explains. This is a greatly simplified version of what goes on when DNA is replicated. A group of molecular machines called ENZYMES travel along the DNA, first splitting it in two, then using each strand as a template to make a new complementary strand. We cannot show you all the parts involved, such as the teeny device that runs ahead of the replication machine and snips one side of the DNA so that it can twirl around freely instead of getting wound up too tight. Nor can we show you how the DNA is proofread several times. Errors are detected and corrected to an amazing degree of accuracy. See the, see the diagram on pages 16 and 17. The narrator continues, what we can show you clearly is a speed. You noticed this robot moving at a pretty good clip, didn't you? Well, the actual ENZYME machinery moves along the DNA track at a rate of about 100 runs or base pairs every second. If the track were the size of a railroad track, this engine would be barreling along at the rate of over 15 miles per hour. In bacteria, these little replication machines can move 10 times faster than that. In the human cell, armies of hundreds of these replication machines go to work at different spots along the DNA track. They copy the entire genome in just 8 hours. See the box, a molecule that can be read and copied on page 20. That's the end of part 4. Bye for now.